Hi YouTube, this is 2006 Core 4 paper when the new specification came in. Question 1, an equation of the normal to the curve given. So applying implicit differentiation and simplifying and factorizing gives an expression for the gradient, and then substituting the values from the point given gives the gradient for the normal as minus 7 over 2. Then applying the straight line formula gives the equation required. So the expression for the gradient of the normal, and the equation. And the sketch here shows the curve and the normal. Question 2, a series solution given f of x, partial fractions in A, and then a series expansion to x cubed in B. So given the form required for the partial fractions in A, multiplying both sides by the lowest common denominator gives the identity here, and trying x equals a half and the coefficient of x, we can write down the expression required. So for the series expansion, using the binomial expansion, taking out a factor of a half and minus 3 over 2, and applying the binomial expansion to x cubed, simplifies to here, which gives the series required. Question 3, a volume of revolution. The area of the shaded section in A, and rotating this around the x-axis in B. So for part A, integrating and evaluating gives an area of 12 between 2 pi and 0. So for the volume of the solid generated, considering the volume formula, y squared is 9 sin squared a half x. Considering the identity for cos 2x, then sin squared a half x will be a half minus a half cos x. And adjusting the integral of integrating and evaluating gives a volume of 9 pi squared. So the integral given in A, the integration, the exact value, and the integral given for the volume, the exact value. The sketch here shows the volume being generated. Question 4, trigonometry parameters. The equation of the tangent to the curve, where t is pi over 6, and then a Cartesian equation in B. So differentiating for parameters gives an expression for the gradient, and then substituting our given value of t gives the gradient of the tangent as 1 over root 3, and using our given value of t, substituting in the parameters gives a point. So the straight line formula and then gives the equation of the tangent. So for a Cartesian equation, considering the expansion of y, we can see that sin t is x, and then considering cos t, considering the identity sin squared t plus cos squared t equals 1, and cos t will be the square root of 1 minus sin squared t. So we can write down the Cartesian equation. So the expression for the gradient of the tangent, the point of the tangent, and the equation, eliminating, and the Cartesian equation. Question 5, a geometry, or given an equation for the line L1 and a point A, to find A and B in A. Then we're given that P lies on L1 and OP is perpendicular to L1, where O is the origin, to find the position vector of P in B. And given a point B, to show that A, P and B are collinear in C. So for part A, we can write down the vector equation from the equation given, and from observation we see that 0 is 6 plus lambda, A 19 plus 4 lambda. And the first expression gives lambda as minus 6, and then we can evaluate A as minus 5, and B will be 11. So for part B, given that P lies on the line from the vector equation, we can write down the position vector. So given this line is perpendicular to the line given, then we can use the dot product of the normal to evaluate lambda. So using the normal from our line 1, 4, minus 2, the dot product should be 0. Evaluates to lambda as minus 4. So substituting in the position vector for P gives the position vector required. So for part C, showing that A, P and B are collinear, we have values for A, P and B, so we can write down direction vectors of A, P and PB, and we can see that there is a ratio of 2 to 3, which proves A, P and B are collinear. So for part C, they're collinear in a ratio of 2 to 3. The sketch here shows A, P and B. Thank you for watching. I'll start question 6 in the next video.